Hello everyone. Today's lesson is on composite function, which is really just a function of a function. But let's say we have two functions, f, f of x, and g of x. When you combine it together, or I still saying f of x and g of x. Let's say f and g. When you combine it together, you get this and this. Now it looks a little bit complicated and a lot right now, but when I get to an example, it'll look mad easy. Just drop my phone. Anyways, here's an example. Determine the equation, trying to find the equation or something. So if f of x, f is x squared and g of x is x plus 3, determine an equation for each composite function. Okay, now something to not forget. To determine an equation for a composite function, substitute the second function into the first. So the second into the first, not the first to the second, or the second to first. Let's go to an example. So as you can see over here, so F is your first, G is your second. So sub the second into it, and the second is x plus 3. And then when you do that, your F is x squared. Just add the x squared into this. And since this is your x, you're just making x squared, which equals to bracket x plus 3 squared. Because that is your x. You're making your x squared. And x plus 3 is your x. Not the x inside, not this x. This entire thing is your x. I hope you get that. Now this question, g is the first and f is the second, which means x squared, this is your x right now, x squared. And then when you add the second one, x plus 3 into it, you're really just adding plus 3, which makes your function x plus 3. Now let's get into more complicated, but it's pretty simple. I won't lie to you. It's an application question. So let me read our record. The number of rabbits are, so R signifies rabbits, and a Wi-Fi reserve as a function of time t, so t is time, in years can be modeled by the function R bracket t equals to 50 cos t plus 100. The number of woes, which is signified by W, equals to W bracket t equals 0.2 R bracket t minus 2. Now there's something I said. Your W is your first function and your R is the second. So all you're really doing for this one is taking this function and putting it into this one. So this, you just replace the R. So just add 50 cos, but instead of making this t become t minus 2, because remember, this is still here, t minus 2 instead of just t. So t minus 2, so 50 cos bracket t minus 2 plus 100. And the reason why it's changed over here is because you simplify it. So you take a calculator and multiply 0.2 times 50, you get 10. 0.2 times 100, you get 10. Now, a real world application, something that we use, I would assume, use it day to day, consider how big AI is in my life right now. So artificial intelligence, computers make decisions by applying functions to the result of another function. So really, it's all just a bunch of functions multiplying constantly to get you what you want. So an example is, let's say your GFX or process, like you take an image. Oh, what is this like cologne or something, right? So the GFX processes the raw data, the FFX analyzes it, and to find what it is, they'll combine each other to give you the person to ask an answer, which is shown by this right here. So really, each AI layer takes the output of one function and feeds it into the next function. I hope that kind of simplifies it, and just keeps stacking and stacking and stacking. Like, what is this little thing in there? What's the brand? What's this? What's that? Every little F, G, X, everything just combines and multiplies to get you, well, to get you what you're looking for, the answer you're looking for. It happens in a quick second, so you never really truly notice it. So bottom line, AI systems work by composing functions, which is exactly what composite functions more than math. So it's literally just compressing functions, which is what well the topic today, composite function is. But anyways, thank you for coming on me and learning composite functions. I hope you get it. Thank you.